Hi everyone, welcome to Lecture 5 on epistemic probability. The objectives for this video are the following things. After watching, everyone should be able to: Number 1, define the epistemic probability of a statement. Number 2, describe the certainty model of knowledge. And number 3, explain how epistemic probability varies according to the addition of new knowledge. Now, last time we introduced the concept of inductive probability and how it applies to arguments. So let's get started with a question for some recap and reinforcement of that. So we said last time that the inductive probability of an argument is the probability that its conclusion is true given that its premises are true. It's a measure of the strength of the evidence that the premises provide for the conclusion. And the point is that inductive probability applies to whole arguments. We made a big deal last time about the fact that it does not depend on the premises or conclusion of an argument alone. The premises/conclusion of an argument considered on their own, of course, are not arguments, they are statements. That's why it's not correct to say that the inductive probability of a premise is this or that, and the same for a conclusion. Inductive probability applies to arguments, and premises or conclusions on their own are not arguments. However, there is a sense in which we can speak of the probability of a premise or of a conclusion. So here enters another type of probability different to inductive probability, one that applies to statements rather than arguments. And we call this type of probability epistemic probability. We'll come to the definition a little bit later on. Now, the epistemic probability of a statement varies across people and times, since people know different things at different times. For example, the epistemic probability that it's sunny in Irvine might be different for my mum in England, who thinks it never rains here in Irvine, than for me, who can see a storm floating in towards Irvine across the ocean. So epistemic probability varies between people in this way. Now, it can also vary across time for the same person. My epistemic probability that it's sunny in Irvine on any given day, for example, has decreased since I moved here, because before I came, I too thought it never rained in California. But since I've moved here, I see that sometimes it does. Now, something that's important for us is to understand how the epistemic probability of a given statement might decrease or increase when you learn something new or you add something to your existing stock of knowledge. So let's get an example on the table. Here's an argument. It says, the Democrat Party candidate received 51.4% of the total vote in the 2020 election. Sarah lives in LA, therefore the chances Sarah is a Democrat is roughly 51%. Now, suppose we're interested in the epistemic probability of the statement that the chances Sarah is a Democrat is roughly 51%. Now, the inductive probability of this argument is maybe moderately high based on the stock of information that we're presented with. However, suppose I tell you some new information, that the Democrat Party candidate received 71.04% of the total vote in LA County. So here's a question. What do you think happens to the epistemic probability of the statement that the chances Sarah is a Democrat is 51% in light of the new information? Now, in light of the new information, the epistemic probability of that statement that the chances Sarah is a Democrat of 51% decreases, because it's now equal to the inductive probability of the following argument. This one says, the Democrat Party candidate received 51.4% of the total vote in the 2020 election. Sarah lives in LA. The Democrat Party candidate received 71.04% of the total vote in LA County. Therefore, the chances Sarah is a Democrat is roughly 51%, which is quite low. You would expect the chances that Sarah is a Democrat to be nearer the 71% mark, based on the new stock of information. So in this way, the epistemic probability of a statement can change with the addition of new information. What's important to understand, though, is how it changes. The decrease we saw in the epistemic probability of the statement that the chances Sarah is a Democrat is roughly 51% came about not from a change in the inductive probability of one argument, but because when we added new information, a different argument, a second argument, which had an extra premise in it, became relevant in assessing the epistemic probability of the statement that we're interested in. So, we've seen that from a stock of knowledge, we assign certain statements a certain epistemic probability using inductive logic. Now, exactly how inductive logic assigns these statements these epistemic probabilities depends on how the knowledge is characterized. Depends on what knowledge is, how we get it, and so on. For now, we'll assume the following model that characterizes our stock of knowledge. It's called the certainty model. It says that our knowledge originates in observation, that observation makes particular sentences or observation reports certain, and that the probability of other sentences is attributable to the certainty of these. Now, there's nothing weird going on here. Let's have a look at the last argument we saw. So the premises, or the stock of knowledge, were the following sentences. The Democrat Party candidate received 51.4% of the vote in the 2020 election. Sarah lives in LA, and the Democrat Party candidate received 71.04% of the total vote in LA County. So these sentences, or observation reports, are rendered certain by observational experience. For example, I looked those stats up on Google. So that stock of knowledge then determined the epistemic probability of the conclusion, which said that the chances that Sarah is a Democrat were roughly 51%, and in fact it determined that probability to be quite low. So in general, the certainty model gives us a natural way of evaluating the probability of a statement. We look at an argument with all our stock of knowledge as premises, and the statement in question as the conclusion. And that's why we define epistemic probability for the certainty model in the following way. We say the epistemic probability of a statement is the inductive probability of that argument which has the statement in question as its conclusion and whose premises consist of all the observation reports that comprise our stock of knowledge. So the certainty model assigns epistemic probability 1 to each observation report in our stock of knowledge. Now, notice that this is something of an idealization, and we'll talk about some other models of observation later in the course, but this one's good enough for us now. So let's pause after hearing a lot of me talk. Here's another question to reinforce all of this. This type of problem we'll see on the assignments too, so have a good think about it. Okay, so let's have a little recap and take stock of what we've seen so far in the course. So we've started with deductive logic at a basic level, and deductive logic is well understood. Its basic concepts are precise, and the rules we use to determine deductively valid arguments are rigorously formulated. Now, on the other hand, there are no universally accepted rules for constructing inductively strong arguments. There's no general agreement on how we ought to measure the inductive strength of arguments, and there's no precise definition of inductive probability. Now, of course, we gave a definition and we played around with some examples so that we could get an intuitive feeling of what inductively strong arguments look like and what inductively weak arguments look like. But the idea of probability it involves is imprecise. The probability that an argument's conclusion is true given that its premises are true. So here's one question we still have. What is inductive probability? So what is the probability that an argument's conclusion is true given that its premises are true? And closely related are a couple of other questions. Here's one. How do we measure inductive probability? And here's two. What are the rules for constructing inductively strong arguments? Now, obviously, we need to know what inductive probability is to know how we ought to measure it. And to come up with rules for constructing inductively strong arguments, we need to know how to measure the strength of arguments, so we know which ones qualify. Now suppose we can do all that. Suppose you can give a precise definition of inductive probability, a corresponding way of determining the inductive probability of arguments, and a system of rules for constructing inductively strong arguments. Then we call those three things an inductive logic. So here's an immediate problem. Different definitions of inductive probability will give rise to different inductive logics. So what do we want from an inductive logic? How do we go about constructing the right one? Now, the book talks about a few things we want from an inductive logic. We'd want something like a system that accords with our common sense and scientific practice, so it would assign a high inductive probability to those arguments we intuitively think have a high inductive probability. But we want more than this. We want a system that makes precise, explains, and refines those intuitions that we have. Now, we call such a system a scientific inductive logic. And one of the main problems of inductive logic is constructing a system of scientific inductive logic. And now this gives rise to another problem, which is where this course is headed next in week 3. And that problem is this: how you would rationally justify the use of a system of scientific inductive logic rather than some other system of inductive logic. Now, historically, this is also called the problem of induction. This second question has a big old history in the philosophy of science. So we're going to trace the history of thought around this question, the second one there, and address it before we address the first question up there. So the problem of induction is what we'll talk about next. So finish off with your self-reflections, and I'll see you next time.